of the number of coyotes n of t in a population is directly proportional to 650 minus n of t, where t is the time in years. When t equals 0, the population is 300, and when 10 equals 2, the population has increased to 500. Find the population when t equals 3. What do we need?
Need the 2 points. So 0 to 30 and 2 to 100.
So they do give us 2 points. Why do they give us 2 points? For a growth model. So we do need a growth model. However, we do need to be slightly careful. Because remember that our growth model said that the rate of change was directly proportional to what? Do you remember? So remember we said the rate of change of, so like in this case it's an n, so that's okay. But it would be the rate of change of n is directly proportional to n in order to get just like a standard growth model. Notice here in ours, is it directly proportional to just n? No. Which means that we can't use just the like standard plug-in chug model. We like it when we can, but there are some instances where we can't. So in this case, we actually have to set up a differential equation and solve it in order to find our model first. Are we all with me? Okay. So instead of writing n of t, we're just going to let it be n. So we have that our rate of change, so dn dt, is directly proportional to 650 minus n. Yes? But remember that even though it's directly proportional, what do we also have to have there? Because they're going to grow and decay at the same rate, but they might not necessarily start at the same spot, right? So what do we have to add in the front? K. Our constant of proportionality. And because it's directly proportional to all of that stuff, that K has to be multiplied to all of it. Does that make sense? We all with me so far? Not? Maybe? So, here we're going to then use our separation of variables. Okay, so what do we want to do with our dt? Multiply. Okay, and then what are we also going to have to do with the 650 minus n? Divide. So we're going to end up with dn over 650 minus n equals k dt. So are we all separated out? So can we integrate now? Yep. Okay. Now be careful here, because what are we going to have to do in order to integrate that? Use sub. So we're not going to have any extra like numbers because it's just an n, but we will end up with an extra negative there. Does that make sense? So when we integrate, we're going to have a negative, and we would just have 1 over u. Well, what is the antiderivative of 1 over u? The natural log of the absolute value of u. But in this case, our u was 650 minus n. Are you okay with that? Okay. And then what is the antiderivative of k? So with respect to t. So k is just a constant. So what? kt. And then we do have to have a plus c. Okay with that. All right. So then, again, remember that we want our model to be in terms of n, because n is like our population. So we do want to solve this for n. So what do we need to do first? We cannot exponentiate it until it is by itself. So we need to divide by a negative. So we get negative k t minus c. You could put it as plus c. Yep. The only thing that's going to change is then like if whenever we use our initial conditions, we solve, and you got a negative, right? Then it would be a negative. But then when we solve, we would get a positive C because we still have a negative there. Does that make sense? So you just need to be careful. Don't put too many negatives or leave out the negatives. That's all. So then now what can we do? Exponentiate both sides. So our natural log goes away. Okay. But I still have absolute values. So then our last step is going to be, what do we need to do? We do, but what would we probably do first? So what can we do with the C, or what have we done with the C in the past?
Brought it to the front.
We brought it to the front, okay? And then because that C can be positive or negative, we can just drop our absolute values at that point. Okay. So then now the difference between like what we did before is like this would have just been n equals that stuff, okay? Except this time we have to do a little bit more solving. So we would need to subtract 650 and then divide by a negative. So that is our model in terms of K and C. However, they give us initial conditions in order to help us solve for K and C, which is why they give us 2 points there. Which one is it helpful to plug in first? The 0. Okay, so we're going to plug in 300 for our n. And we just get C times, if I plug in 0, what's going to happen to our E? It's going to be 1. So we just get plus 650. So what does C end up being? Negative 350. Now, do notice that like in our previous one we talked about, C was our initial population if we don't have anything else coming like after it. In this case, notice that here, as long as this number, it's okay if it's negative, as long as it's smaller than whatever we're adding. Because if I plug in 0, I would still get negative 350 plus 650 still gives us that 300. Does that make sense? So that's why it's slightly different, and the C isn't just 300, because when we start adding or subtracting things here, that's going to affect that C value. So then what is the last thing now that we have to solve for? Okay. Now, what type of model do we have here? Is it growth or decay?
Decay.
Looking at what it tells us in the instructions.
Growth.
It's a growth model, which means that eventually we need this K to be positive, right? So when we solve, we should end up with a negative. That way we have a negative negative, and it ends up being a positive number right there. Because remember, it's a growth model. If K is positive, a decay if it's negative. So we're going to use that second point. So 500 equals negative 350 E to the negative 2K plus 650. What do we want to do first?
Subtract the 650.
And we get, okay, and then we, by a negative 350, we want to divide by negative because we need to end up being positive. What is 150 divided by 350? So we get 3 7 equals E to the negative 2K. Then what can we do? Now let the E's by itself. Take the natural log. And our E goes away. And what do we have? So then last step to solve for K. We get K equals negative 1/2 natural log of 3/7. Agreed? Which we wanted a negative, so that's good. Okay.
So whenever it's negative, it's in row?
So notice here, we already have a negative in our K,
Yeah.
but we have a negative, which
Oh,
makes
so
it
it's
positive.
positive.
Yeah. So that's why we wanted our K to be negative, because we already had a negative.
Oh, yeah.
That's right. So we get n equals we have our C was negative 350 times e to the, we have a negative, so 1/2 natural log of 3/7 C. Yes, and then we have our plus 650. Yes. So if it just asks you for the model or the function, that would be your answer. Okay? But it asks us to find the population when t equals 3. So then what are we doing? Plugging in 3 for t. And then just plugging all of that into your handy dandy calculator. And what do we get? Oh, type for me.
Probably way higher.
Yes. No.
No.
Your answer is way higher.
551.8.
551.8 what?
0.
Okay. Now, we're talking about coyotes, so we're not really going to talk about point something of a coyote. So we're going to go ahead and round up. And we're going to say that there are 552 coyotes. And that would be yay. Which, if we look at our model, right, we're going from 300 to 500, from 0 to 2, okay? Then we're only increasing by, like, another hour or year at that point, right? So it shouldn't increase quite as much as it did from 0 to 2, but it should still be increasing. So we are above 500, and it didn't increase quite as much, but not as much time passed. So that answer makes sense. What questions do we have?